In this lesson, we're going to talk about what happens when we start to change the shape of how these alkanes get together. So we've taken a look at alkanes in a chain, either a continuous chain, where it's just, a straight chain, butane, pentane, heptane, all that kind of stuff, and we've taken a look at branched ones. So those are still considered to be chains. Now what happens when we take that chain and we decide, well, we're actually going to make a cyclical or a ring-shaped molecule of this so that there's no beginning and no end. And what we get there is a class of compounds called cycloalkanes. So again, cycloalkanes are saturated because there's only single bonds, but instead of taking that kind of straight chain form, they have a cyclical form. That changes the general formula. Okay, the general formula for cycloalkanes is CnH2n. And if we compare that with the general formula for regular alkanes, which was CnH2n minus 2, we can see that in cycloalkanes we're missing a couple of hydrogens. Where did they go? Well, these last two hydrogens here, that should be a plus, these last two hydrogens here represented those hydrogens on terminal carbons in the chain. So you know how end carbons in the chain, if this is a chain of any length, we'll just call it R. All the chains for alkanes will end in CH3, okay? And remember that 3 is just on the terminal carbons, so the last ones in the chain, the ones on the interior of the chain are either C's or CH's or CH2's. So because we don't have an end of the chain anymore, we're getting rid of these CH3s and they lose hydrogens, and therefore that's what happened to those two extra hydrogens there. When we name cycloalkanes, we name them by writing the prefix cyclo in front of the alkane name. Let's look at an example. And actually this one that's up here is a little bit more than I want to start with. I want to start with just really, really simple. Okay? So what happens when there's no branches and we just have a cycloalkane that looks like that? Okay? I bet your math teachers didn't tell you that triangles were actually cycloalkane compounds. Probably didn't come up. Okay, let's take a look at what's happening here. Here is a cycloalkane, and this is where I finally start to appreciate line diagrams as opposed to just with straight chain alkanes. So our line diagram shows us that we have 3 carbons, right? We're going to have a carbon at each of these intersections. How many hydrogens, if we want to make this a condensed structural formula kind of written over top? Well, they're all going to be CH2. And then you can see that follows the general formula CnH2n. Okay? If we were to name this as an alkane, we would say, oh, okay, cool, there are 3 carbons in this chain. So that 3 carbons, that's prop, and it's all single bonds, so that's ane, so propane. That would be if these were 3 carbons in a straight line. However, these are 3 carbons in kind of a ring structure, and so what we need to do is we need to add the word cyclo in front of the parent chain name or the alkane name to make that compound cyclopropane. Just that easy. So those rules, guys, that I gave you for naming alkanes, we're actually going to be working, those are like the base. We're going to be working off of those rules for naming all sorts of different compounds, all the different compounds that we're going to end up seeing. We're just going to add some things or change some of the details for the different compounds. So this is one thing that we're going to add, is this prefix cyclo here. Now we're ready to look at this, this particular example here that's given on your page. If we take a look, we can see, well, this ring structure that's drawn has 6 carbons in it, right? It's in a hexagon, which means there's 6 carbons. 6 carbons means hexane, and because it's in a ring, we have cyclohexane. Our next step is going to be to number the chain so that we can find out where our branches are at. Okay, so when you have a cycloalkane as your parent chain, again, when we do that numbering, we want to give the branches the lowest possible number. Now, looking at this compound, there's a bunch of different ways that I can number, and I can go either in the clockwise direction, or I can go in the counterclockwise or anti-clockwise direction. Okay? In the beginning, this is going to take a lot of guess and check for you. I'm going to give you a little tip in just a second that will let you know kind of how to make sure you've got the right one. So, taking a look here, I could start numbering really at any of these branches. I know one of these branches is going to be number 1. So which one is it going to be? Well, if I start here, number 1, okay, and I go clockwise, 2, 3, 4, 5, and 6, I get branches at 1, 2, and 5. Now, a tip that was given to me that I thought was really, really helpful is when you have these branches, their locations, the number of their locations, need to add up to be the least possible number. So here, if I have branches at 1, 2, and 5, that adds up to 8. Okay, good. Is that right? Well, let's just find out. Where else could I start numbering? I could start numbering here, 1. And now I could go anti-clockwise or counterclockwise, 2, 3, 4, 5, 6. Oh, okay, well now I have branches at 1 and 2 and 4. If I add those together, that makes 7. Okay, well 7 is less than 8, so perhaps that's the right one. If you guys want to play around with this and work on numbering this cyclohexane ring to see if you can come up with anything lower than 7 or what you come up with when you put numbers in different places, that's cool. I'm going to tell you that this one actually is the lowest, so I don't know why I just erased that. There's our branches. Or sorry, there's our numbering of our parent chain to give us the location of our branches. All right, cool. So when I'm identifying my branches, I can see I've got 3 methyls. I'm just going to abbreviate this stuff a little bit. So I've got 3 methyls, which gives me a prefix, or a pre-prefix is what we're calling it, of tri. And where are those branches located? Well, they're located at 1, 2, and 4. 1, 2, and 4. When I put this name together, I'm going to follow the exact same pattern that I followed if I was just using regular alkane name. So I'm going to have 1, 2, 4, trimethyl, cyclohexane. 1, 2, 4, trimethyl cyclohexane. Let's make sure that we are remembering our punctuation. So commas separating numbers from other numbers, and dashes separating numbers from words. On to the next one. Okay. So here we have a 5-carbon ring. 5 carbons is pent, remembering that I need to call this cyclo because it's in a ring. My parent is cyclopentane. Now what am I going to do about my branches? So my number 1 priority, guys, is to number this chain so that the branches have the lowest possible number. So that, again, if I add up the number of the branches, I give them the lowest possible number. Well, it should make sense, hopefully, to you guys that we need to start right here where I can give 2 branches the number 1 spot. Okay? And then if you're looking at this, do I go clockwise? Do I go counterclockwise? Well, clockwise would be your best choice. If I went counterclockwise, then this branch here would be at the number 4 spot. No, I don't want that. I want it at the number 3 spot. That's the lower number. What are the names of my branches here? Off the first carbon, I actually have 2 methyl branches, and I know that calling this 1, 1 seems a little bit redundant, and it is. However, it's just the rules. I didn't make them. I'm just telling you about them. Let's go with that. So 1, 1 dimethyl, that's our first branch, but let's not forget, off the third carbon, I've got a branch that has 1, 2, 3 carbons in it. Prefix for 3 carbons is prop. Suffix that indicates it's a branch is il. So 3-propyl. Challenge yourself. Pause the video right now. Put this name together. See if you come up with the same thing I do. Again, we need to alphabetize these branches because we have 2 different ones when we put the name together. And when we alphabetize, we don't count the D for di, no. We just count the M for methyl. I know that either way that's going to come before propyl, but just make sure. 1,1 dimethyl, 3 propyl cyclopentane. So hopefully this makes sense to you. This isn't too much different from what we did with naming alkanes, and if you understand that, as I said, that forms the base for naming all the compounds that we're going to take a look at. Really, all we've done today is we've added 5 letters into the mix, and hopefully that's not too much of a stretch for you guys. You have your assignment to do. It is online, so enjoy that. Write down your score out of 20 and show me.